G'day Trendsetters, Greg here from Fishplay Films and welcome back to the Birdwood Subdivision. Now, as I promised you, we're going to do a video today about how to wire your tracks on the initial stages or in your pre-planning for CTC signalling or block working or block signalling down the track. We're going to be using one of these. There's a BD20 block detector. We'll have a look at one of these a little bit later on. And essentially what one of these is, they're a current transformer. And a current transformer is used to measure normally large amounts of current without having to run huge amounts of current up to an amp meter. Something you might find in, I don't know, maybe one of these, a locomotive. So, you know, locomotives have their traction motors can draw up to 2,000 or 3,000 amps. I think in normal running they're about 1,500 amps, 600 amps. You don't want that amount of current going up into your cab, into your display on your little board. So how do you do that? How do you measure huge amounts of current safely? Well, what you do is you use a current transformer, a much bigger version of one of these Trendsetters. And you put the high current carrying cable, something coming out of a traction motor, and you run it through the guts of a coil, and they're basically a big coil like this, and they have lots of turns in them, and they are a transformer. So your huge inrush of current that's going through to, say, your traction motor or whatever it might be, generates a small electric field, and that small amount of current is then sent to an amp meter or a digital display or something like that. We're sort of doing the opposite here. We're taking tiny little bits of current from our track, because remember, when a loco goes past, that's fine, but we want to be able to detect rolling stock. And of course, we don't want to put so much current through our track like a short circuit to detect stuff that will close the whole thing down. So we're only trying to detect 1 or 2, maybe 3 milliamps per freight car. So that's, you know, quite difficult to do. So we use a CT, but we sort of do it the other way, and it steps the current up so we can read small amounts of current, and it comes out of here in a signal, and you can do all sorts of things with it, and that shows your signaling system where your train is. That's how all signaling systems work, as to detect the presence of a train. So this train here is on a passing siding, and it goes from a turnout just around the corner there, and it comes up behind me back here somewhere. So what we need to do, we need to detect the current from anywhere on that block. So we've got some feeders here for this track. We can't just hook our BD20 through one of these feeders here. Now we only need to use this on one track. So you can detect either the positive or the negative. We'll get into that. We're going to go into the classroom, Trendsetters. So it doesn't matter. But you just can't put it on one, because if we put a loco on any other track here, it will probably work, having this just on one feeder in that section. But if you put a freight car with a 10 k ohm or 15 k ohm resistor on it right around the other end of the loop here, the current is going to go through the feeder near that end. It's not going to go through here. So what we need to do is, on this section of track here, from where it starts to where it finishes around here, there are insulated joints on each end. We need to get all these feeders, combine all of those for that whole section of track, put it through our block detector, and then back to our track bus. So we need to make a third bus with all these feeders on the feed. So let's go into the classroom now, Trendsetters, and we'll have a look how to do that. But first of all, we'll show you BD20 a bit closer and show you how it works. Okay, here is our BD20, and as you can see here, this is our wire that goes through the current transformer, or the CT part. We've got our hole there. Now, this wire is way too big, but I just did this big so you can see it. And those of you who don't know what the BD20s, they can be powered from 5 to 12 volts, I think. So I've got 12 volts on this one. Well, I will have. So our positive comes in on the bottom. No, I think that's number 4. Neutral or negative at the top, number 1. And number 2 is our switched 5 volts. So that goes to our signaling system. And number 3 down here, that's a switched negative. So I will be using, where are we there? I will be using these to run relays, as we've said before. So I will be using this switch negative on number 3 to switch my relays on and off for my signaling. Just in the meantime. But of course, if you're if you were going to do it for, I'm working backwards here, if you were going to do it for, as you normally would for a CTC system, you would use your logic output, which is number 2, up the top there. And of course, your wire, normally what I've found is that to get the best triggering, you go through once and then wrap it around and come back through, so 2 passes through the CT. Right, here we are, here's our BD20 with a loop, just 1 loop around, so the wire goes in, 1 loop around and once. Now that's what I have found normally to give you the best detection with the least amount of current. Okay, we're back in the classroom again, trendsetters, and this is our rough overview of our track plan and how we're going to be wiring up for our block detectors. And we've seen a BD20, we know what they're like, what they do, how they work, and we'll just have a quick look at how we would wire one up just for one section of track, and then we'll go through this scenario here and we'll have a look at how it's done for normal DCC wiring, and then how we would do it if we were going to get it ready for CTC wiring and install some block detectors or BD20s. Okay, here is our block detector, here's our track. We've got our insulated rail joins here and here, and this is our feed coming off, one feed off our track, through our BD20, through a circuit breaker and to our command station. So that's simple for one block of track or one section of track. And it's only got, this one's only got 1 feed, so I'll have a look at how we normally do it and then we'll do it for a couple of feeds. Now this is our main line through here, and we've got a siding going off in here. This is any part of any layer. Any layer, every layer is a main line and some sidings. That's about it. And you may have a loop somewhere, but essentially it's all the same. So normally we would have our bus along here. This is our track bus. It's twisted, as we should do. And we have our feeds coming down. That's easy enough. We've got our neutral and our active. Remember, it's not positive and negative, it's active and neutral because it's AC. And we're dropping them down and they're coming along. And this is a longer section here, so it's got a feed at each end. Now you might be one of those crazy people that puts a feed at every length of track if you want to, but for this sake, it's got a feed at this end and it's got a feed at that end. This particular section here also has a feed at each end, one here and one here. And if we go back down here, this section, short section of rail here, only has 1 feed, and if we go up the other end, this section from here to here, from here to off the board, oh no, where is it? There it is, here. This has 3 feeds. So this is a really long section. So, normally, we've got our feeds coming down, and they all go to our bus, to our circuit breaker, which is this is one power district section, to our circuit breaker, then of course to our command station. Now, these things here are our insulated rail joins. We've got one there, we've got one there and one there because this is a electrofrog point. So you would normally have an insulated rail join there and there, or an insulated fish plate, trendsetters. And for the purpose of, we've got another one here, because this will be a section, and we'll have another one up the other end here for this section and this section. But for now, normally we wouldn't have those insulated rail joiners there, would we? No. We would have these, but we wouldn't have these ones. So what we'll do now is we'll change this track over to how you would wire it if you were going to make these sections, this one, this one, this one, and this one, all into separate blocks for your CTC signaling. So let's do that. Now this is our short section here, and you can see we've come from the positive rail this time, and we're going down through our BD20 and straight onto the positive bus. That's easy, or should I say the active bus. That one's easy, and then that of course goes back to our circuit breaker and into our command station. Now, the next one, this gets a little bit more complicated here. So we'll zoom on this and we'll have a look at that one. Now remember before we said we put our insulated joins here and here, and here for our turnout, for our electrofrog. So we're going to use those as our gaps for our rail. So in this passing loop here, our common rail is this one here for our detection. So we'll come down off that rail, through there, and we have to common this up, because remember, we have to see all the current from the whole section, not just one end. We have to see the whole section has to go through the BD20. So we effectively have a third bus. So this is our, let's call it our detection bus, or whatever you want to call it. So we're going to feed from this end, our feed from this end, bring it down, common it up here. That goes through your BD20, and then that can go to the neutral bus, because this is our neutral rail. And the active, or the positive, remember we only need to detect one rail, it can go straight down like it always does to the positive bus. That's fine for that one. Now on our main line, because we've got our insulated joins here and here, we're going to use the positive, or the active rail, as our detection bus. So same thing, but only with the other polarity. We're coming down off our active rail, down through here. We've made another bus through our BD20. Oh, no, trendsetters, that's wrong. That shouldn't be there. We common both of our feeds up, so we've got a feed at this end and a feed at this end. Common them up. Our BD20 should be here. Ha ha! That caught myself out, trendsetters. So we've come from our active rail down through. We've made another bus here. That we should have a BD20 in there. I know it's all getting a bit confusing, this drawing, isn't it? And then that goes to the active rail. So we've got, for our passing loop here, our neutral rail is commoned up into a third bus, goes through our BD20 and then to the neutral rail. On our main line, we're using the active, because we've already got the insulated fish plates there, so we may as well use them. Same thing, down through here, a new common bus. There's a new common bus through here. Then that common bus goes through our BD20 and joins to the active feed. So remember, whatever section we're doing, all that current has to go through the BD20, not just one feed, because electricity will follow the path of least resistance. So we'll show that on this last section over here. Right, now remember, this is our last section here. This is our long section. It's got 3 feeders in it. So we've decided we've put an insulated join here and an insulated join there. So that's again on our active rail. You can call them positive and negative, but they're actually active and neutral. So we need to get rid of, we need to common these feeders up. So let's do it, we'll do it up the top here, so it's a little bit less. Now we haven't got any insulated joints here on this one, so that's fine. So they can go to the neutral bus and stay on the neutral bus there. But our active one, this is the one we're going to put through the BD20, so we need to make a new bus. So here's our new bus. Up through there, up through there. So this is like our third bus, this is our detector bus. So you have a common neutral bus, a common active bus, which is your normal track bus. And then you'll have a third bus for every detection. So this is our third detection bus here, this time coming off the active rail. So come along there, join all them up. Now that bus can go up through here, through our BD20, and then it can come around, and because it's an active, it can go back and join up to our active rail there. Okay, it's a bit roundabout, but that's giving you an idea of what we need to do to get these BD20s working. Now remember, they have to, there's no point, if we just put a BD20 here and say, okay, well that's, you know, the train's going to come along and some current will flow through here while the train's here. But as it moves along this section, if it gets down to here, the current is not going to flow through there, or not very much. Most of your current is going to flow through here. So that's not going to work. All your feeders for a section that you want detected have to go through the BD20 or whatever detector you're using. So we have to common this up, common them up through our BD20 and back down to the original bus, whatever that was. Now some people like to put a circuit breaker in on each of their BD20s. That uses a lot of circuit breakers, it's up to you what you want to do. But if you're running, say this, all this is in one power district, then all your BD20 feeds can come off your normal track bus, and then that track bus then goes through your circuit breaker and back to your command station. Clear as mud? All right, we'll go back to the layout and we'll have a look at how we're doing it on there. Yes. Now, you're probably wondering before we go, trendsetters, why we didn't talk about the turnouts. Now, a turnout will have its own track, normally starting from somewhere before the turnout and encompass all three routes of the turnout. So the approach of the turnout, or the facing part of the turnout, and the two trailing edges of the turnout. It will have its own track. And the purpose of that is that will tell the signalling system when a train is on the turnout or on the approach tracks to a turnout, so the signalling system won't throw a turnout underneath the train. Now, that becomes more expensive because you're going to need another BD20 for every turnout. So if you've got 40 turnouts in your layout, then that's another 40 BD20s, which is, in Australia, another $800. So for the purpose of the signalling to start with, you don't need turnout tracks. We call them points tracks, or I don't know, in America you might call them switch tracks or switch track circuits or whatever. But for the purpose of this exercise, we won't be dealing with the turnout track, which is in here. So you'll notice we stop this section here, and we start the section there, and we start another section there. So this section here, through the turnout itself, is a dead section. If you want to make that a live section, then that's more money, and of course it's more prototypical for signalling. But for the purpose of showing you how to wire your tracks initially for CDC signalling, we don't need the turnout tracks. They're easy to do later on. One really easy way to do it is to use your feed going to your frog, and that will tell you when a train is at least on that part of the turnout. Some people make it a whole dedicated track, but you can always do that after. But for initially wiring in, this is what you really need to know. So that's why we haven't covered turnouts. Okay, trendsetters, so there you go. That's our quick course on how to wire your layout for C2C block signalling, whether you're using a BD20 or maybe some other block detector. They all work roughly the same. They all rely on a small amount of current being drawn by your rolling stock. Locomotives aren't a problem, of course, because they draw more than enough. But we want to detect our rolling stock. That's the biggest thing. So we want to be able to draw the smallest amount of current. Remember, you've got 200 cars on a layout, 100 cars. Even if they're drawing 3 milliamps each, that's still 300 milliamps, which isn't too bad. That's about 2 locos, but you don't really want them drawing too much more than that. So that's the idea of these, to detect the smallest amount of current as possible. So a good trick, and we'll do this when we get to actually wiring the BD20s up, a good trick, and what I found is with one pass of the wire through, it wasn't enough to do the old dry finger test. So what you can do is you put a dry finger across the track. If these are set up enough and you have enough sensitivity in them, you will trip the detector, or trip the detector, I guess, or make the detector work with just your fingers. That's enough shorts across the track, So that's an guide. You can get right into it. It gets very technical. You can read a lot of technical stuff about these, different milliamps and sums and all that sort of crap. But what I found, and what I watched a lot of other videos as well, if you can get this to trip with a dry finger across the joint, that's good. That's the smallest amount of milliamps that you want. You don't want it too small, because then of course it won't detect at all. And you don't want them detecting too high a current either, otherwise you'll start shorting things out. So somewhere around there, looking at about, somewhere between 3-4 milliamps of current to trip your BD20. But anyway, so that's why, and a very, very eagle-eyed person on the update of number 22, when we were looking at these feeders here, noticed that it wasn't soldered. Damn people with 2 good eyes. And to be quite honest, it's just between you and me, there's quite a few joints in this layout that aren't soldered. Still works. Because a lot of these have to come off. So that's why. Anyway, that's it for now. We'll see you back maybe when we're installing some of these. And I hope you learned something. Hope it wasn't too boring. And we'll see you on the next layout update, or the next tutorial. So for now, it's Uri from the Burbers Hub. Bye-bye. Oh, by the way, that was a Atlas Dash 8 and what's it? Yeah, the ST78 still running in. Yeah, whatever. Okay. Bye.